Hello, welcome back. This is our next video. I want to just point out something. I messed up on cutting my hair. I've got to get new clippers. My clippers decided they didn't want to cut hair anymore. So I'm going to have a pirate look going today, just because I don't want you to be distracted while doing math on my really terrible haircut. Okay? So it's for you. So we're going to talk today about exact equations. Now, exact equations, they are related, actually. Let me write this here. Related to conservative vector fields, which if you did those, you may have done those in chapter 13 of Calc 3. Some of you did, some of you didn't. I know I did touch on them in my Calc 3 class, but I don't always get to them, okay? So let's remind ourselves what conservative vector fields are. Let me change that to black. Okay, so a conservative vector field is a vector field P of x, Q of x, such that there exists a function, and normally we think of it as 2 times differentiable, continuously differentiable, f of x, y, such that P of x equals the derivative with respect to x of f of x, y, and Q of x, sorry. This is actually P of x, y, and Q of x, y equals the partial with respect to y of f of x, y. Okay? Now, if we remember about twice differentially continuous functions, we may remember that our second partials are equal. Okay? So then, partial of p with respect to y, which equals the second partial with respect to y with respect to x of f of x, y, should equal the other mixed second partial, which is the derivative with respect to x of q. Okay. Oh, let me move this thing slightly. Never mind. Yeah, let me move it this slightly. Sorry. This is now my third take on this, so I'm not going to start over just because of that. Okay. All right, so let's start with an example. Show y e to the xy plus 2x, x e to the xy minus 2y. Show that it's conservative. And find the generating scalar field or generating scalar function. So right now, this is all stuff that you may have done in Calc 3. Okay, this is not yet differential equations, but the process is going to be exactly the same. So that's why I'm doing it this way first. Okay, just in case you have seen it. And those of you in my class that took my class for Calc 3 would have seen this. Okay, so first thing we're going to do is we're going to say, okay, P is y e to the xy plus 2x. Q is x e to the xy minus 2y. Partial p with respect to y, that's what we needed to check, is going to be, well, e to the xy plus xy e to the xy, right? Because we're doing derivative of this with respect to y is 0. So we're just doing the product rule here. Okay. Partial q with respect to x is going to be e to the xy plus xy e to the xy. Okay, good. These are the same, right? So that means we have a conservative vector field. Now we're going to go back to P and Q and find these generating scalar function. Okay, so let me play around with this a little bit. Like it. There we go. That's better. Okay. Now, let's go ahead. We're going to find the generating scalar function. So what we're going to do is we're going to take the integral of P with respect to x. And what's that? That's the integral of y e to the xy plus 2x dx. That's going to be, now this is with respect to x. So y is treated as just a constant. Okay? So this is going to be the integral of y e to the xy is going to be, well, let's see, e to the xy, correct, plus x squared. And now we're going to add on an idea that there is an arbitrary function, let's call it g, of y here. Okay? Because if we take the derivative of this expression with respect to x, we are going to get this expression, right? Okay? So P, so this is our f of x, y. So P, remember, is the partial of f with respect to x. Now we're going to do the same thing with q, except for now we're going to do the derivative of q with respect to, or I'm sorry, the integral of q with respect to y. So remember, we've assumed that p and q are the elements of the gradient of our scalar function. Okay? So our q is up here. Let's go ahead and bring it down. We're going to integrate that with respect to y. Okay. Similarly, we're going to get e to the xy minus y squared. Plus, we're going to call, let's call it h, of x. Okay, so just like up here, we're going to have q equals, sorry, that bothers me, q equals our partial of f with respect to y. So now we have this expression for f of xy and this expression for f of xy. We're going to match them together. So they both have an e to the xy, so that's good. This one has an x squared, which we sort of think of as being part of that h of x. This one has a y squared, which we think of as being part of this g of y. So our f of xy is e to the xy plus x squared minus y squared, and we're going to go ahead and say plus some constant. Okay? And that's the conservative force field. Now, let's take a look at the problem. Well, let's actually go to the next page, so I'll see you in a new video.